Hi friends, in this video let us solve a signal system related question asked in GATE 2012 EEE paper. The question is the input x of t and output y of t of a system are related as y of t is equal to y of t is minus infinity to plus t x of tau cos of 3 tau into d tau. We have to find whether the system is time invariant or stable or unstable. Okay. So here you see this is input, this is output, right? But another time parameter tau, it is scaled. Since we know that since time parameter is scaled, surely it must be a time variant. It is time variant. Okay. So time invariant is a wrong answer. Right? So A and C are wrong answer. So how can we prove this? Let us assume y of t is equal to x of at. For time invariant, what we will do? We shift the input. So y of t comma t, x of at minus t. This is equation number 1. Then what we will do? Shift the output y of t minus t. So x of a t minus t. 2. 1 is never equal to 2, so time variant. So always if your time parameter t is scaled or shifted, it is time variant system. So the first thing is it is time variant system. Okay. Next we have to find whether it is stable or not. Okay, so from here you see we give some bounded input. Bounded input produces bounded output, means it is a stable system. For x of tau, I will give some bounded input cos 3 tau. Cos is always a bounded input because cos is having a magnitude of 1, plus 1 to minus 1. The input is bounded. So if I give like that, it will become cos squared 3 tau into d tau. Cos squared 3 tau minus infinity to t. 1 plus cos 6 tau by 2 into d tau. So if I integrate, surely the answer will become infinity because it will become t, integral t. So t by 2 it will be. So t by 2, when I substitute t is equal to infinity, so it will become infinity. So it is unbounded. So it is not stable. So it is not time invariant and it is not stable. So option D is a right answer. It is not a stable system, right? So option E is also wrong. And option B, stable. This is also wrong. The problem given here is unstable and time variant. Thank you.